Welcome to the video tutorial on significant figures. So significant figures are a very elegant and subtle way to communicate how accurately we know the value of a measurement. So the rules of Sig Figs, these are just something you want to memorize, all right? So significant figures, they're the digits in a measurement known with certainty plus one estimated digit. So you could think of the estimated digit as the uncertain digit. And I like to symbolize it, right? The estimated digit is the uncertainty, and that's the question mark. That's where we guess. So when we're reporting measurements using Sig Figs, we're communicating the magnitude of the measurement, but also how accurately we understand the measurement or how much we can trust it. So when we're looking at measurements, it's very straightforward. If we have non-zero digits, we know that they're always significant. And so remember, this is the definition of significant up here. So non-zero digits are either the digits we know with certainty, or they're the estimated digit that we guess. It's the zero that can cause the challenge. The digit of zero. The zeros may or may not be significant. We have to look at the location of the zero in the number. All right? So here, with leading zeros, this is a pretty good one. I like this one. I don't get to say never very much. The zeros located at the beginning of a number are never significant. And what I'm going to do is I'm going to go through the rules and I'll do some examples, and then we'll practice on the following pages. Confined zeros. Those are the zeros located between non-zero digits. They're always significant. And then trailing zeros. So trailing zeros, you're going to have to depend on who your instructor is. In my class, we follow this rule for trailing zeros, that the zeros located at the end of a number are significant if the number has a decimal point, or the zeros carry over bars. All right? Some professors and textbooks call this ambiguous, and so you're going to need to just defer to what your professor says about the rules. So now let's see how these rules work. So for example, if we had 2,583, these are all non-zero digits. So if we looked at this as a measurement, we would say that we know the 2, the 5, and the 8. Those are certain. We know those absolutely. The 3 is the uncertainty. So the rule of Sig Figs say that we take all the digits we know for sure plus the first estimated digit, and that determines our significant figures. So we would say that this measurement has 4 Sig Figs. Now, significant figures is a mouthful. They often get described as Sig Figs, and I will reduce it just down to SF. All right, now let's bring in those zeros to see how they work. All right, so let's say that we have 0.002583. All right, so these are the leading zeros. Leading zeros never count. So if we are looking at this number, we say we know the 2, the 5, and the 8 with certainty, and we're guessing on the 3. So once again, 1, 2, 3, 4. 4 Sig Figs. Okay? Leading zeros never count. Confined zeros. Zeros located between non-zero digits. Let's say we had 2003 as our number. These zeros are confined between the non-zero numbers of 2 and 3. So this tells us we know the 2 and the 0 with certainty, and we guessed on the 3. So once again, we're looking at a number with 1, 2, 3, 4 sig figs. Alrighty, now comes the last option for zeros, and that's the trailing zeros. So this is where the decimal point is critical. So if we have 2,500 and we put a decimal point, then what we're telling everybody is we know the 2, the 5, and the 0 with certainty, and we guessed this last digit, and we happened to guess it to be a 0. So according to the rules of Sig Figs, 1, 2, 3, 4, this number would have 4 sig figs. Now, if we write the number 2,500 and we leave off the 0, that's telling us that we have no idea what's going on here, that our first guess, our guess is happening at the 5. So we know the 2 with certainty, and we were guessing in the hundredths place. Now it's important, think about money. So these zeros are here as important placeholders. So the value is around 2,500. We do not know this measurement very accurately. We're guessing in the hundreds. So we would describe this as having 2 sig figs. What happens if we wanted to show 3 sig figs here? Well, we can't put a decimal point. This is where we use the overbar or sometimes the underbar. We put an overbar here to let everybody know that this is where we're guessing. So we know the 2 with certainty, we know the 5 with certainty, and we guessed 0 here. So this would be an example of 3 sig figs. So the key with trailing zeros is to focus your attention on the decimal point. When the decimal point is present, then we say that that these zeros are here as part of our measurement, and that the question mark is in this position here, the ones place. Without the decimal, we're letting everybody know that we guessed in the hundreds place. And if the decimal doesn't work, then we can bring in the overbar or the underbar. So then to wrap this up, to kind of finish up this page here, if we said how many sig figs are in this measurement, right? Here are the leading zeros. They never count. Here we have confined zeros. They always count. And here we have trailing zeros, and we do have a decimal point, so they're going to count. So we would say 1, 2, 3, 4, 5, 6, 7, 8. There would be 8 sig figs. And really all significant figures are telling us is that this is where our guess is occurring, in this last 0 place. So now that we have an overview of the sig fig rules, let's give you a chance to practice applying them. So what happens is we'll do a calculation, and our calculator is going to spit out a result that's going to have a ton of digits, but we're going to need to round to the correct number of sig figs. But remember, sig figs are all about where is the question mark, right? We got to keep the value the same. Alrighty, so if we look here, if our calculator spits out the number 6,478, but we only want to report 2 sig figs, that tells us that this is where the uncertainty is in our data. So we look to the right and we see that we have a 7. right? So 7 is greater than 5, so we're going to round up. So if we are going to report this measurement to 2 sig figs, it would be 6,500. So the zeros are the important placeholders because they help us keep the overall value. In this next example, we have a bunch of leading zeros. Leading zeros never count. So if we want to do 2 sig figs, 1, 2, so that's telling us this is where our question mark is. So we look to the right and we see 3. 3 is less than 5, so we round down. So we bring in, right, leading zeros never count, so we bring in all the leading zeros and then we would put 7, 9. So now we have rounded this measurement to 2 significant figures. Here we go. Now we have a nice big number. So think money. Imagine that you just won $456,924 in the lottery. All right? So we want to report this to 3 sig figs. That's telling us 1, 2, 3. It's letting us know that the 6 is where our uncertainty is. We look to the right. 9 is greater than 5, so we round up. So we would rewrite this number 457,000, right? So sig figs is just about the details. These are important placeholders, right? They keep the overall value. All right, so here we have 1, 2, 3. So sig figs are all the digits we know with certainty plus the first guess. All right, so let's try a couple more of these, make sure everybody's clear. We're back to leading zeros. Leading zeros never count. 1, 2, 3. So our uncertainty is here at the 0. 7's greater than 5, so we're going to round up. So leading zeros never count, so there's the 0. Now we start counting. 1, 2, 3. So now we've reported our value to 3 sig figs, recognizing that that's telling us where our guess is. And then this last one is to remind us about the overbars. So 2 sig figs, 1, 2. That tells us this is where we're guessing. We're guessing in the hundreds place. So we would rewrite this as 4, 0 with an overbar. Or we could use scientific notation and do 4.0 times 10 to the third. And if you're not sure how I'm jumping back and forth between these two values, there is a video tutorial on scientific notation to help you. And the main thing to keep in mind is that sig figs are telling us where the data starts to be uncertain. So this is a huge, important distinction, right? The zeros are important placeholders. Whether they're leading zeros or trailing zeros, they preserve the overall value of the measurement, right? The sig figs are about the accuracy and the precision of the measurement. So go ahead and take a few minutes to round the numbers below to the correct number of sig figs and then compare answers with me. So in this first example, right, so we want 1, 2, 3, 4. So this is telling us that the uncertainty is in the 4th position. So if we look to the right here, right, 3 is less than 5, so we round down. So when we report our value, 6, 8, 9, 5, 0, 0. So we would take this huge number and we got to maintain the overall value. We're just letting everybody know where we can where we trust the results. And then if we reduce this measurement to only 2 sig figs, right, so then 2 sig figs tells us this is our question mark. So now we would look at the 9, and the 9 is greater than 5, so we round up. So we would report this value as 690,000. And so remembering that sig figs is just telling us how trustworthy the measurement is, and the zeros are the important placeholders to keep the overall value. And then a little bit of practice with numbers with the leading zeros. So here it's important to remember that leading zeros never count. So 1, 2, 3, 4. So in this first example, it's telling us that the uncertainty appears at the 6 in the number here, this digit here, represented with the 6. So if we rewrite it, it would be 0.0, right? Leading zeros never count, so then it would be 2, 7, 8. We would round up because of the 9. Oops. That should have been a 7. I'll rewrite that. Well, I think it's clear. So leading zeros never count, 2, 7, 8, 7. So we round up, we round the 6 up to a 7 because of the 9. Okay? Or if we only want to report 2 sig figs, we're going to stop here at the 7. So leading zeros never count. So that would be 0.002. The 7 is next, there's an 8, so we round up to 0.0028. Alrighty. Now now that we've had some practice with significant figures, let's look at how they're used in calculations. Okay, so the guiding principle here is the worst data, right, the least accurate, the least precise, limits the result. So, with multiplication and division, the result is limited by the term with the smallest number of significant figures. So if we look here, we see 1, 2, 3. So we have 3 significant figures in this first measurement, but we only have 2 significant figures in this second measurement, right? So significant figures are all about where we're guessing the values. So if we multiply these 2 measurements, our calculator spits out 18.33. Okay, and then here's our units. That would be feet squared. And so once we have our result with our units, we look back, and this is our worst data, 2 sig figs. So now we need to round our answer to 2 sig figs. So that would be 18 feet squared. So we're letting everybody know that this is the guess in the ones place. For this next example, 5.0, we have a trailing 0 with a decimal. So that's 2 sig figs. And here we have 3 non-zero digits, 3 sig figs. So, and in this one, we see that we have milliliters on the top and milliliters on the bottom, so we have some units canceling in our calculation. So we're left with grams. If we punch this data into our calculator, the calculator tells us that we would get 69.5 grams. And once we have our final result, take a moment to look back. The worst data is 2 sig figs. So now we're going to round this to 2 sig figs. 1, 2. Notice there's the 5, so we round up. So when we round 69.5 up to 2 sig figs, it's going to be 70 grams. But remember that we need to show 2 sig figs and we have a trailing 0. So to let everybody know that the uncertainty is here at this 0, we add our decimal point so that we have a 2 sig fig answer. The vast majority of the calculations that we do in chemistry involve multiplication and division. It's very rare that we need to do addition and subtraction. Mostly addition and subtraction show up in calculating molar masses, which we'll learn in the future, or doing temperature conversions. So the applications for addition and subtraction with sig figs are pretty limited, but there are a couple places where we need to use the rules, so we'll practice them. So when we're doing addition and subtraction, the rules are different. The result is limited by the term with the least precision. So how do we find the least precision? We look at which digit place has the uncertainty. So when we're looking at this first calculation, we see that the first measurement, the uncertainty is in the hundredths. Right? It's in the hundredths place, 2 to the right, 0.0, like 1, right there. That's where we're not sure, in the hundredths place. With the second data, we're uncertain in the tenths place. This is where we're uncertain, right? So which data is worse? Definitely, right? Tenths are bigger, right? So tenths are greater than hundredths. So that tells us this is the worst data. So we do our calculation. So we get 9.65 feet. So we're just adding here. All right. So now we want to round our answer. So because we have uncertainty in the tenths position, and that's the worst data, we limit our results. So we would round this to 9.7. Fives will round up, 9.7 feet. And then here's one more example without decimals. When we look at this first value here, there's no decimal, so the uncertainty is in the hundreds place. Right, so we're in the hundreds. That's where we're not sure. When we look at this second measurement, it's uncertain in the ones place. Right? Okay, so 100 is bigger than 1. So this is our worst data. So we go ahead and do the addition. Okay, so we get this result, but now we're going to round, right? We're going to round to the hundreds place because that is our worst data. So this final answer would be reported as 600 grams because our uncertainty is right here and the 6 is greater than 5, so we round up. So our final answer would be 63,600 grams. Alrighty, so that concludes the significant figures tutorial. Please take the time now to work a few practice problems and do some calculations so that you're comfortable working with sig figs, especially in calculations.